Well, good afternoon, everybody. Hope you all had an enjoyable lunch. My background is in geology. I've been an exploration geologist for a number of decades now. And one of the things that's really been amazing is the change in the amount of like remote sensing imagery that's become available. When I first started working in the field, we had black and white 1 to 80,000 aerial photographs, and we had 1 to 250,000 topographic maps, and that was about it. Fast forward to today, we've got high resolution images like from Google Earth. We've had the Landsat series up for quite a few years now, and we're now getting Sentinel data, which is also 10 metre resolution anywhere in the world essentially, and it's really quite an amazing set of data. So what I'm going to talk about today is mainly how I see using the new data coming from the hyperspectral satellites for use in geological mapping and mineral exploration, but it also goes into the environmental side, looking at vegetation analysis as well. So this is just an example of some hyperspectral imagery from the Prisma satellite, being put up by the Italian Space Agency. The spectral data is 30 metre resolution, but they also supply a 5 metre panchromatic band, so you can pan sharpen this 30 metre resolution down to 5. So it's really amazing the amount of information that you can get out of it, and I'll give you a run through today and show you the way I've been playing around with it. Okay, so the question is, why hyperspectral imagery? Well, this is a sort of a wavelength map that shows what our eyes can see in the red, green and blue. But there's a whole pile of other wavelengths there in the electromagnetic spectrum that these satellites can detect and we can use to analyse the surface materials. This is why using the hyperspectral data, you can get a lot more information from it. There's a number of multispectral satellite data which have been around for quite a while now, and a lot of this data is available from the NASA Earth Day data portal or the ESA, European Space Agency portal as well. And these include satellite sensors like ASTER, Landsat and the Sentinel stuff. ASTER has been in operation for probably for 20 odd years now, and that's quite commonly used in the mineral exploration game, as is in the Landsat. Whereas the Sentinel is a bit newer. I commonly use a Sentinel-2 data, which is a 10 metre resolution. So again, I tend to look for the free data first, and if you're after a more high resolution stuff, then you might have to buy some data from a supplier. Okay, when we're talking about satellite data, we're talking about the spatial and spectral resolution. The spatial resolution relates to the size of the pixel on the ground, so it might be 30 metres, 10 metres or whatever. And then you've got your spectral resolution, which is the resolution of the wavelengths that the sensors can pick up. So for example, the Landsat 8-9 series, they've got a 15 metre panchromatic band, and then they've got 30 metre pixel sizes for the visible near-infrared and shortwave infrared bands. The ASTER has got three different sort of pixel sizes depending on which sensor you're looking at, 15, 30 and 90, beg your pardon, for the visible shortwave infrared and the thermal infrared. Some of the commercial stuff that's available, for example, is Worldview 3, where you've got a 30 centimetre panchromatic band, and the visible near-infrared bands are 1.24. So it sort of varies on which sort of sensor that you're looking at. What I'm going to be talking about today are the hyperspectral sensors that are available now. One's called EnMAP, and that's been put up by the German Space Agency, and Prisma, that's been put up by the Italian Space Agency. Both of these hyperspectral satellites have a 30 metre spatial resolution, but their spectral resolution is in the order of 5 to 10 nanometres. So you get a lot of information out of this data. Okay, when we talk about hyperspectral imagery, this is what we're trying to dig up here. We're trying to get as much information across the broad spectrum as possible, so we can characterise the various minerals. And with the Prisma and the EnMAP data, you have to go on to the relevant website portals and register to get a login. But the data is free, but it's not available everywhere around the world as yet. But they're working on it. These satellites have only been up for a couple of years, so they've still got a fair bit of time to go. And why do we need more spectral bands? Well, the more spectral bands you have, the better definition you have of the actual spectral response of the surface. So the top red line up there shows you what some of the older Landsat data was giving you. So it's only had about 4 bands. Then the Landsat thematic mapper had 6 bands, so you're getting a bit more detail. And then the HiMAP, which is a commercial hyperspectral satellite, I think that's 120 odd bands. And if you had a field spectrometer where you actually take a box out in the field and stick it on a rock, then that'll give you about 2,000 bands. So the more bands you have, the better, to help you differentiate some of the materials. So this is just a bit of an example of some of the different sensors. The grey shaded areas there are areas where the atmosphere is transparent. The white areas there are where the atmosphere absorbs the sunlight, so we're not getting any response back to the satellite. So you can see that most of the bands are all concentrated in those grey areas. Sentinel-2 there, you've got a number of bands, some in the visual, near infrared and the shortwave infrared. Whereas you look at the bottom one there, the line where it says HiMAP, that just shows you what the hyperspectral data gives you. It gives you a lot more information in all of the different bands. The way I usually play around with this hyperspectral data is I use a QGIS plugin called EnMAP-Box. And this has been specifically written for QGIS and for handling the EnMAP satellite data. It also imports the Prisma satellite data as well. It's a pretty amazing toolbox, and I'll show you some examples of what I actually do with it. And again, it's a free download to QGIS. It gives you access to all sorts of different algorithms and processing. The main thing to remember is before you install this, go to the EnMAP-Box plugin website and read the install instructions, because you have to install some dependencies before it'll run. And so when you go onto the website, it'll give you a list of things you need to do. I usually install the dependence via a pip command, and it's relatively straightforward. Then once you run it, you can either run it directly from your processing toolbox in QGIS, or you can open up its own little window. And this will then give you access to the data. You can see that it also imports a number of other products, the indices, EMIP and so on there from the International Space Station, I think. But there's also the Prisma and Sentinel data there. So there's lots of different things that you can import. And then when you've imported some of this data, if you open up the layer style styling box on the right-hand side of the app, you can see that you can choose set sort of combination to RGBs. This is an RGB combination for natural colour, and it tells you which bands it actually uses, because you're looking at 220 spectral bands here, so it helps to know which bands to actually combine for your RGB imagery. There's a lot of information in here, and you can also click on a pixel and you can get the spectral response, going from 400 to 2400 nanometers across the scale there. So a lot of information, and it's an amazing tool. For example, you can also bring in spectral libraries. This is part of the USGS spectral library, and you can play around with that sort of stuff as well. And so what it does, once you've opened it up, you can then play around with all this data in QGIS. You can use different sort of band combinations to suit what you're looking for. I typically use all this stuff for geological mapping or geological interpretation. And the good thing about it, on the left-hand side there, you'll see that it gives you the band number and it gives you the wavelength of those bands. So you've got quite a lot of control on how you want this stuff to be displayed. And then the other thing that you can do with the EnMAP-Box as well is you can export these 220 bands into different raster formats. For example, if you want to put it into Hyperspectral Python software, for example, you export it as a BSQ file, for example, which you can then read into these other software packages as well. Without EnMAP-Box, this would be a lot more complicated process. The other thing that's got pre-installed in it is a big pile of spectral indices. This is some of the vegetation indices that you can run, and this is a standard with the installation of the EnMAP-Box. I'm a geologist, so I don't understand most of what that all means, but I'm sure there's probably other people who probably know a lot more about this than me. So there's also tabs on that one for burn, water, snow, drought, urban, and you can also add in your own spectral indices as well. So as I say, an amazing piece of software, completely free. And there's also a set of vegetation indices that you can do here as well. For this particular one to run, you have to save them out as a BBSQ file, and it'll run these vegetation indices. And you also can create your own NDVI, for example. I'd like to make life hard for myself, so I've created a graphical modeler in your QGIS, so I can then use QGIS to extract various bands, do sort of band ratioing and so on, and I can combine them into RGB images or whatever other sort of style images that I want. And then you can create images. This is an adonite image from up near Roburn, and you can filter it. You can pull out all the high zones, for example. So this is really good for looking at alteration mapping. I also do accommodations as various ratios just to enhance the geology. So this is the ferrosilicates and the ferric ion alteration and an MgOH band combined together to try and maximise the different geological features. This is some environmental stuff as well, looking at vegetation health on a particular image. So you can see where it's sort of blue, it's then green on the natural colour image. And the last couple of examples I've got just to show you how I use it with the geological mapping. This is the Mordor complex, that bluey sort of thing here, just to the east of Alice Springs. So this is the 250 thou map. And if we pull in some of the EnMAP data and process it, then we can get an image like that, which shows you some of the geology quite well. So you can see that the amount of detail that you're getting is greatly enhanced. So particularly if you're looking down at this area down here on the bottom left, you can see that it's really enhancing extra information in there. So I'm open if people want to come and do some extra collaboration on this and get some of these things into QGIS. I'm more than keen to have a chat.
Cheers, Grant.